Good morning, students. In previous class, the topic is matter around us pure. From this topic, we have learned more and more. As a part of recapitulation, I am going to remind all the important elements and separating process. We all know that matter can be divided two types. One is pure substance, other one is impure substance. Again, pure can be classified into elements and compounds. And a mixture is the important example of impure substance. Further, mixture can be divided homogeneous and heterogeneous. Solution is the best example of homogeneous, and suspension and colloidal particles are the best example of heterogeneous. Pure substance. What is pure substance? The substance which is made up of same kind of particles, and pure substance can be divided elements and compounds. Next one is a mixture. What is meant by mixture? Mixture contains more than one pure substance and can be divided a homogeneous mixture and heterogeneous mixture. Homogeneous mixtures, compounds can be mixed with uniform composition, whereas heterogeneous mixture, the compounds can be mixed with a non-uniform composition. Best example of homogeneous mixture, salt and water, and sand and water is the best example of heterogeneous. Based on the properties of homogeneous and heterogeneous, we can discuss true solution, colloidal solution, suspension. Salt plus water is the best example of true solution because it is a homogeneous mixture. And sugar plus water is the best example, true solution. Egg albumin, it is colloidal solution, of course heterogeneous. Milk, colloidal solution. And another example, hemoglobin in the blood, colloidal solution. Sand plus water, best example of heterogeneous mixture. And moreover, the important property, that is size of particles, true solution, the particle size is less than 10 power minus 7 centimeters. Colloidal solution, the particle size is in between 10 power minus 7 centimeters to 10 power minus 4 centimeters. Suspension, more than 10 power minus 4 centimeters. Another units, true solution, the size of the particles less than 1 nanometer. Colloidal solution in between 1 nanometer to 1000 nanometers. The particles in the suspension more than 1000 nanometers. Tyndall effect, it is the light phenomenon. Whenever the light is passing through solution and colloidal particles and suspension, the path of the light is visible in the case of colloidal solution only. Tyndall effect occurs because of scattering of light. This is main reason the size of the particles in between 1 nanometer to 1000 nanometers. Therefore, we can say that true solution, there is no Tyndall effect. Colloidal solution, there is Tyndall effect. Suspension, there is no Tyndall effect. Colloidal solution having Tyndall effect because of the size of the particles in between 1 nanometer to 1000 nanometers. Now let us discuss separating techniques, that is separating components in a mixture. The first one is how we can separate two immiscible liquids. What is two immiscible liquids? Liquids cannot mix with single phase. Best example, oil and water. How we can separate oil from water? With the help of separating funnel. Let us take oil and water in the separating funnel, we can easily separate. Second one is how can we separate two miscible liquids? That is nothing but distillation process. Now, what is the distillation process? the process which is used for separation of components of a mixture containing two miscible liquids. Two miscible liquids means the liquids can mix with a single phase. So I have taken two immiscible liquids, that is acetone and water. How we can separate? These are taken round bottomed flask consisting of thermometer and heat it. First of all, acetone will vaporize and passing through condenser. Through outlets of the condenser we can get acetone. So for distillation process have sufficient difference in their boiling points. This is the process to separate two miscible liquids in the process of distillation. Of course, it is the lab activity. Next one is another modified distillation, that is fractional distillation. What is the fractional distillation? It is separating process which we can separate two immiscible liquids which the difference in boiling points is less than 25 Kelvin. For example, air is a homogeneous mixture and can be separated into components by fractional distillation. First, air is consisting of so many gases. I have taken three gases, oxygen, argon, nitrogen, whose boiling points are minus 183 degrees centigrade and argon minus 186 degrees centigrade and nitrogen minus 196 degrees centigrade. Now air is going to compress it by increasing pressure, decreasing heat energy. Then air is converted liquid air. Further, it is allowed to warm up slowly in fractional distillation column. Then what happens? The gases get separated at different heights depending upon their boiling points. So here nitrogen is having less boiling points, that's why it can come out first, next argon, and finally we will get liquid oxygen. So this is the fractional distillation, a separation of components of air. First of all, nitrogen and argon come out, and finally we are having liquid oxygen. Another separating technique, separating process, that is chromatography. What is chromatography? Chromatography is the process separation of components of a mixture, and simply we can separate so many solutes presented in one solvent. So activity: take a thin strip of filter paper. Second step, draw a line with the help of pencil. Put a small drop of ink, and next immerse the filter paper into the water. Here what happens? As the water rises on the filter paper, it takes along with the dye particles. Here the important thing is the colored component that is more soluble in water rises faster, and the colored component that is less soluble in water rises slow. Applications of chromatography: first of all, we can separate colors in a dye. Second one is pigments from a natural colors, drugs from blood. Let us discuss activity related to chromatography once again. Take a thin strip of filter paper and drop red color ink, green color ink and blue color ink. Dissolve it with water. What happens? We are going to observe. Here blue colored component rises faster because it is more soluble in water, whereas violet color rises less. Why? Because it is less soluble. Another important process that is crystallization. What is crystallization? It is separating process to separate a pure solid in the form of its crystal from a solution. So it can be separated in the formation of crystals. How it will be? Take copper sulfate solution, add water, it will be converted copper sulfate solution, and further filter. Some of the impurities will be removed and evaporate it. Then copper sulfate solution is converted into saturated solution. The saturated copper sulfate solution will be covered with filter papers and leave it at room temperature. Further, it will be cooled slowly, and finally copper sulfate crystals will be obtained. Copper sulfate crystals, that formula is CuSO4 5H2O. Sodium carbonate and sodium carbonate crystals, formula is Na2CO3 10H2O. So this is the copper sulfate powder, anhydrous copper sulfate. So this is hydrate copper sulfate or copper sulfate crystals, CuSO4 5H2O. Once again I am going to remind the separating process, that is evaporation process. In this evaporation process I have taken the mixture salt and water. Water is a volatile component and salt is non-volatile component. So here volatile components can be separated from salt. Salt means non-volatile, by using the technique of evaporation. With the using of this technique, we can separate salt from water. This is the important technique. So what is the evaporation? Evaporation is the process to separate volatile components from non-volatile component. Another important technique, separating technique, that is sublimation. I have taken the mixture salt and camphor. Here sublimation means which can separate volatile sublimable substance from non-volatile sublimable substance. So I have taken the mixture camphor and salt in a china dish and heated. First of all, camphor is converted solid state to vapors directly. After cooling, again camphor will be deposited at solid state at the walls of container. This is the way of the process to separate sublimable substance from non-sublimable substance. Thank you.